Well, hello again, and welcome back to Level 1 Chats, the man who needs no introduction, Mr. Kroah Hartman. Welcome.
Welcome. Thanks for having me.
Oh, no problem. How are you? How are things?
Things are good. Went on my first trip in 2.5 years for work. It was interesting, but not to get back in the swing of things.
Yeah, I had my first trip was like 3 weeks ago. I went to Austin for the Milan X launch, more cash. But yeah, that was definitely weird, first time traveling.
Yeah, it's weird getting back on planes, going to airports, things like that.
It's do you find that you've adapted to the extra time and you're using it efficiently from not having to travel?
I'd like to think so, yes, but I it's hard to tell. It's nice, relaxing. I did just order. I got a new pair of slippers. I wore out a pair of slippers in 2 years, just being at home, so not leaving the house,
Shuffling around the house.
Yeah, so that says something about where I've been. So.
Yeah, I've forgotten how to travel pretty much. It's like navigating the airport.
Yeah, I was like, oh, where? And actually, I was like, where are my electronics? And then I was like, oh, my headphones are the seals were all corrupted and corroded. I was like, I had to go buy new headphones. And, yeah.
Do I have all of the cables that I need for travel?
Exactly.
Yeah. I went through a little bit of that myself. It was it's nice to be out, but there's definitely aspects of travel that I don't miss. So
yeah, I don't miss it either. It's nice to see people again and talk to people face to face. That was good, and I understand that. I'll be in Paris in a week and a half for the Kernel Recipes conference, so I'll be the first time to see a bunch of kernel people.
So I was looking at some of our past emails. You've been rocking Threadripper desktop now for 2 years.
Has it been 2 years? Wow.
It's 2 years, yeah. And it's as far as generations of hardware go, we're basically still there. As far as Threadripper goes, that's still current generation, but there is Threadripper Pro. AMD has sort of realized like we're in this weird spot where is it a server CPU, is it a desktop CPU? I don't know. So Threadripper Pro unlocks, registered error correcting memory and 2 terabyte memory capacities, and the regular Threadripper platform tops out at 256 gigs, and 256 gigs just doesn't go as far as it used to.
This thing's amazing. I am so happy with it. It works great. I had some interesting problems with it the past couple of days, but that's all software and distro related, GCC related. Hardware's been rock solid. So much so that it's been a year. My son and I built pretty much a copy of the same system. So we went out and paid for it all, built it, put it together, and he's running that upstairs.
Nice.
In his area. So yeah, it's amazing stuff. He bought the same case but in black. Different storage, but and we got a better video card, but
yeah. All good stuff. Yeah, well, I mean, it's good if you do it right. You're only upgrading the video card about every generation or every other. You get like the mid tier, and it turns out that's a really good deal versus splurging on the highest end GPU and then sort of suffering in that second generation window.
Yeah, so we found one somehow, and we can run Steam VR stuff on it. It works great.
That's awesome. That's really, really awesome. I'm glad to hear that it's been trouble-free also.
It's been amazingly trouble-free, yeah. I'm so happy with
this. The NVMe setup ran a little hot, so I don't know if you noticed or not, but I put some poster putty, a blower fan with some poster putty in the bottom.
No, I saw, that's what that is. Okay, I didn't see that. I was like, thought that was just the way it was. Okay.
No, that's just me doing terrible things.
That's fine. Well, then that kind of brings me to the question. So I have a bunch of fan brackets from the server that you sent me, but you didn't use them?
Yeah.
I don't know what the fan brackets are for.
So in the front, you've got 2 180 millimeter fans. But if you ever needed to go to water cooling or anything like that, those brackets, you pop the 180 millimeter fans out, and then they mount where the 180 millimeter fans mount, and then you get a vertical slot for mounting like a 360 millimeter radiator or whatever.
Okay.
I think
really want to go crazy.
Yeah, and I think there's 360 millimeters of fans in the bottom, and I think that if you wanted to mount something other than fans there, you would need a bracket for that as well. But I was really
there is a bracket. There's a few other tiny brackets that were in the box too. So yeah,
that's probably what those are for. I was surprised that we were able to. I mean, okay, so everybody's probably already seen the video. I did a separate video on the build, but it's a dual 64 core EPYC server, and it's in a desktop case. And this is a kind of you can't just do this because server motherboards are designed for server levels of airflow. If you look at a desktop Threadripper board and a dual socket board, the VRM heat sinks on that desktop board are enormous, and it's because it's designed for the airflow that you have in a normal desktop case. But the heat sinks on a server board, where you've got twice the power consumption, are comparatively very tiny. That particular case from Fractal is one of the very, very few desktop cases that has sufficient airflow at a low noise level that you can mostly get away with a motherboard like that.
Yeah, the noise levels are really, I mean, like you said in the video, the power supplies are the noisiest things, those fans on that, and which it's still pretty low. It's great.
In messing with the new hardware and like the new platforms and moving from Zen 2 on Threadripper desktop to Zen 3 on server, do you have any experiences you want to share or anything with like some of the new hardware features? Because there's secure encrypted memory. For me, I run Windows, like my Windows gaming stuff is a virtual machine under Linux, and so things like low overhead IRQ remapping is important to me, and PCIe pass through and that kind of stuff. And it's been interesting watching the hardware evolve from earlier generation Epic and Threadripper, and then what's in Zen 3. And so I didn't know if working on any of the plumbing for that kind of stuff was on your radar, or if you've run into any of that, because there's cool stuff under the hood, but I don't know how much it translates into actual real world performance.
There's some cool stuff. Yeah, if I was to run a bunch of virtual machines on here, I could get better virtual I/O. I could do that, whatnot. Actually, my own kernels, I ripped out all the virtualization stuff. So because I didn't want containers, I don't want any of that stuff. I just want a raw kernel to access the whole thing. So yes, if you do run a normal server system like that and you want fast I/O where you don't have direct access to the hardware from a virtual machine and you want pass through, the new CPUs are much better at that. I mean, the original days, the virtualization is like, oh, we just virtualize the CPU. We don't care about I/O. And that's the history of operating systems. It's easy to write a kernel. It's hard to write drivers. Somebody else will write a driver for you. And over time, the hardware's realized that, oh, we have to have pass-through properly. So we have VirtIO and some ways to do NVMe natively through to virtual machines. And that's really fun. And the new NVMe standards and devices like that are much better that way. You can almost assign this device over here to that virtual machine. The CPU, the kernel doesn't even get involved at all, and it just goes right there from the host. The host kernel doesn't get involved.
Yeah, some of that is it's mind blowing, because I know some of the guys that are working on the hardware for PCIe fabrics, and now like what I think of as like a server or something is it's basically all becoming disaggregated. It's like, oh no, we can get like a 30 lane or 32 lane wide PCI Express connection from here to here through the bus, and now the NVMe is actually just up here in the rack, and it becomes a switched interface. But then you have to change things with the way that the PCIe bus is handled. You get like 10-bit addressing and how it handles errors and stuff like that. And it seems like what is the kernel and what the hardware is handling gets blurry really fast.
It does. PCIe is a great example of a hardware standard that's evolved over the time, and it's all hidden from the operating system. So they're like, oh, we'll just make the BIOS handle that, and they handle that in firmware, and it's really cool. And then PCIe got to a point where it's the same as InfiniBand or Unipro. It's all differential pairs. So you can just have to route 2 wires, differential pair. You can go really, really fast with those things. Same thing as even USB. So at the physical layer, it's all the same. They're standardizing it. Now you can start to route these. Like you said, you can take those physical pair, those 2 wires, and put them through bigger systems and route them around. And with the speeds that they're getting, throwing memory is now on NVMe. So you can throw memory out there. And then there's something with CXL or CLL.
Yeah, CXL. Yeah.
CXL, that's some scary stuff. That's just memory out there. But so the trick is it's the memory at a different level. So the kernel's there's a meeting from the Linux kernel memory management and file systems conference last week or 2 weeks ago. And there's an article on LWN about that, how we're going to have different tiers of memory for the kernel. And how do we expose that to user space? And when a program do we tell, like, here's your database. Are you going to run that memory out of this slower memory or this faster memory? How do you move that around? How do you even expose that and tell that to user space? It's going to be an interesting problem.
Yeah.
And they're like, oh, we'll just do 2 tiers. And like, no. I think rumor has it there's going to be 5 tiers coming. It's like, oh, great. But I mean, these are fun problems to solve. Like people always somebody from IBM used to joke with me every year, isn't Linux finished yet? Haven't you stopped? I'm like, well, finally, after years and years of this, I finally came up with the response was, well, when you stop making new hardware, then Linux will be finished. So we have, it's fun stuff. We'll keep doing new stuff and make it look like old machines. That's the fun thing about Linux. It's the same old model from 30 years ago. I got the 30-year T-shirt on here. But you can run that old programs, but you also can run new programs. We have new models of new things like UIO ring to handle fast IO from user space to do the kernel faster. So you can do newer interfaces to evolve and make things work better for newer types of hardware that was never around when old Unix was there. But yet we're still a POSIX system, so you can run your binary from 30 years ago, and that works just fine. And that's really powerful. It's an evolutionary process over time. We curse it sometimes because we have to put up with that old stuff, but it lets us keep our users, which is important.
Have you seen the Steam Deck? What do you think about the Steam Deck?
I love the Steam. I have ordered one. I have not got it yet. I worked with the Valve guys a long time ago when I lived in Seattle. They're great people. They're great developers. They know what they're doing. I have like one of the first Steam boxes. It's great. The Steam Deck it's a great piece of hardware. It's hard to make hardware, right?
Yeah.
It's physically a difficult task and challenging, and they seem like they're doing a good job. Mine's on order. I'm somewhere in the queue. I don't know when it'll come.
I too am in the queue.
Great people working there.
Yeah, I don't have mine yet either, so I can't really. I got the Steam OS working on one of the Minis Forum Ryzen embedded systems, and it's fun to play with. But when you're talking about agnostic and enabling a whole series of things and all the stuff that goes with that, it's like, well, that's kind of what Valve has done. I mean, it's still taken millions and millions of dollars of funding, but in any other scenario, it would have been impossible without Linux underpinning to be able to do that.
Yeah, I mean, the cool stuff is they've dumped the resources into making wine, to add for support for wine and Photon and things like that, to make a porting it look like Windows, right? And so these I've talked to the Valve developers, like these game people that create a game, they ship it once and then it'll never even actually build again because the build machine it was on is gone, right? So you can't ask them to say, oh, just go rebuild your game and it'll work just fine. They can't, it's gone. And talking to the people that actually port games to Linux, it's that same problem. They get this crazy tarball of code that they assume it built on some other machine. Let's port it to Linux. So the fact that they've emulated the system that works that well, it's amazing.
It really is super, super exciting. For that, just I mean, it's easy to never get bored with anything that you're working on because it's literally everything.
It's fun. I have seen the Steam Deck hardware model about a year ago, or maybe my time is gone. 2 years ago, somebody did come out with a Windows 10 little box. I saw on Kickstarter that you could do it from, I think, Taiwan, of course. So if I was in Taiwan, I'd go and try and find one of those.
That is awesome. Plus, it's awesome knowing that you have the hardware. So if there are any bugs that are stumbled across, you're in a position to be able to.
Yeah, I could file a bug for that. Or my son could file a bug for that. Yeah, he's messing around with that.
Excellent.
He watched your video for this for the build, and I pointed it to him, and he had his computer science class watching as well to see how he walked through picking a different CPU. And I mean, it's a great idea. Here's a problem, a real world problem. How do we solve this? And I argue that, they don't really teach this stuff in school. And he's like, hey, we watch this in class. So yes, they are teaching this in school.
Yeah. It was a lot of fun to do a bunch of different testing. There were a couple surprising things there, which is ultimately the number of cores wins out over pretty much everything for this particular build.
And it's all, what is your workflow? You need to figure out what your workflow is and get the right hardware for that. Or you can go the other way. And some big companies are like, we have 3 types of boxes and we're going to assign to everybody. And that works really well when you have to manage 100,000 machines, and it's in the wash. But if you have to manage like 10 machines, hey, try and tune it to what you know your workflow is for.
Yeah. One of the machines that we used for testing was for your kernel process was the Xeon Platinum CPUs that Amazon had retired last generation because Intel sold them better Xeon Platinums, and so there was just thousands of Xeon Platinum CPUs on eBay, and it's like, this isn't even a real model number. What? That's just what Amazon demanded.
SKUs. Well, that's cool. At least their latest generation. Traditionally, Amazon would buy 1-year-old chips from Intel, and they let the rest of the world beat on it and fix all the bugs in Linux first, and then they'd get it and then adapt it. Now they have more kernel people working for them, and they've worked out that, hey, maybe this makes more sense to use the latest one. But for a long time, it was always fun watching Intel engineers always complaining about that. We're not selling any chips until they're a year old.
Is there any other hardware that you've seen or that's upcoming that you're excited about, or anything else? Anything else that you're excited about, technical or otherwise?
CXL was it. I haven't heard of anything new in a while. That's going to take a while. NVMe is fun to play with. There's NVMe to USB devices that are becoming more and more popular. I bought a few off of a local shop, and it's like you can put them inside a little gamer thing with some fun LEDs, but it's an NVMe inside here, and here's a terabyte, which is cool, which is normally you were doing that with normal SSDs as well, but now you can just stick any NVMe size you want in this little container and it works, which is fun. That's a different model. I can see. I bought 2 of them. One of them works. One of them doesn't work with Linux, so I got to figure out the one that doesn't work. What's wrong with that one? That's what we do, drivers. So that's fun. So no, that's about. I haven't been around enough other people from other companies to hear the rumors of what's coming next on hardware, as far as that goes. The things that I hear and see that are good on presentations are like, oh, here's a new CPU thing that's going to come out for that, and honestly, other people like Linus and memory management people, they get excited about that and they go off and do cool stuff with that. Things, new CPU instructions and the way you save registers and interrupts and timers and stuff. That's not my bag of tea or whatever. I like new devices, new hardware type stuff. So CXL was the new thing that we heard about years ago. It's finally becoming popular. I'd like to see it out there. NVMe is becoming more and more prevalent, and it's cool to see. It's showing up in different form factors like USB. I never thought USB to NVMe would be there, but that's there.
Yeah, the 5 and 10 gigabit USB is the protocol. It looks like it's looking more like PCI Express with every iteration, it seems like to me.
Well, it is. At the lower level, it is. It's a PCI Express physical layer. That's exactly what it is. And then you do it. Finally, we have USB storage working well enough that it's not the old school model where it was like, here's a packet. Well, thank you very much. I'll send it back. Here, have another packet. I mean, the original USB storage spec was saying, all it did was says, this is going to work for floppy devices. Go see the SCSI spec. It's like 5 pages long. So it's really slow. I have the very first USB SCSI or floppy disk still somewhere. It's a 3.5-inch floppy drive. They gave them out to us because I worked on the USB spec when they were finally finalized it. That's the old USB storage spec. So then about 10 years ago, they came out with the more modular one, like, oh, let's start streaming things multiple times in both ways. And it actually works better at a protocol level. And now you can just bump up the speed of these more links and whatnot, and then your data just flies. Like, seriously, on this NVMe to USB device, it was fast, really, really fast. So much so that I plugged in a normal old USB stick. I was backing something up to that, and it was overheating, and I'm like, I just need to throw these things away. It's like the old school style. I mean, it's not that big of a difference from the old this to this. A terabyte versus, yeah, it's nice.
This has been very awesome. Thank you again for taking time out of your schedule to share and the kinds of workloads that you're enjoying with your 64
just
cores.
Lots of builds. Oh, and cool. So now I know you're worried about the heat. We talked about it. I was going to put it in the cabinet. I haven't made room for it in the cabinet. I put it in my basement. Like, I'll put there. It's on my 5th floor now because it's tall and narrow. This is the Netherlands, tall and narrow rooms. And it's near an air conditioner vent, which I have. And so it's idling low and it works just fine. And I use tail scale to punch out a hole. So when I'm remote and traveling, I tested this out. I can spin up a kernel build and away it goes remotely. And just works. That's an amazing way to do that as well.
Then the only caution that I would have for you is to just keep an eye on the dust filters. There's one in the bottom and there's one in the front. And if it clogs, the machine will struggle.
Okay. Yeah, I'll watch that. And I'll try and I watch the monitoring of it. And is there any temperature? There's got to be temperature sensors in there. Yeah, I'll figure out how to export that to Home Assistant in the proper way. And I'll monitor it that way.
The IPMI has some pretty extensive for voltages, temperatures.
That's IPMI. You got to run running IPMI is you want the dedicated Ethernet link for that, right? Normally?
You can, but on that board, it can share with one of the onboard NICs. So I think there's just a setting that you toggle in the BIOS. And then if there's no link on the dedicated IPMI, it will share the interface with one of the physical NICs on the motherboard.
Okay, maybe that's why. It showed up, another IP address showed up on my network for some reason for the same box. Maybe that's why I did accidentally. The weird thing, I will say, that motherboard only has VGA out.
Mm-hmm.
I didn't have any only VGA monitors in the house. So I had to go to the store and I was going to buy a DVI to USB converter or a VGA converter. And it turned out I spent €30 more. I bought a monitor.
It's just VGA.
A tiny gaming monitor, Asus monitor, which works out really well. I just need a console for the thing every once in a while. But the amazing thing is it's only VGA. And I mean, I thought HDMI I mean, this is a brand new top of the line motherboard.
Everything
is it because everything goes through IPMI now?
Yes, everything goes through IPMI, and anything that doesn't still probably has the legacy VGA connector. But also, if you put in an add-in GPU, the IPMI can't read the GPU's VRAM, which is how it does that. So the reason that it is the way that it is because I guess all of the intellectual property and everything, it's all just on one system on chip. So you've got one system on chip that's the computer within the computer, basically, but it's just good old fashioned like 1024 by 768 VGA, and the IPMI can just read the frame buffer directly from the VGA, and then that's how it displays it on the web page.
So there's a virtual machine like that. So that thing is probably running Linux in there as well. I know it used to be. Most of those are running Linux in the past.
Yeah, probably the case. Probably full of security holes too. So.
Oh yeah, that's why I didn't want to put that on my. Even on my network that's behind 3 firewalls, I didn't really want to put that on.
Well, I'm glad that you're going to get. You're definitely the appropriate person to be able to use that machine. And AMD was very kind. AMD and Gigabyte were very kind to. Provide support for that machine, and an FSP group for the power supply. So definitely big thank.
Those power supplies they're a little bit loud, but it's fun just to unplug one. It still works. It does that, and they're amazingly tiny. I was impressed.
900 watts in a tiny little package. Yeah,
it's cool. Yeah, is it 900 watts per?
Yeah,
I guess it must be.
Yeah,
they're both plugged in, and it's still only it's not using a lot of power unless it needs it.
Yeah, absolute. If you're hitting that system as hard as you possibly can, it should be on the order of about 750 watts, 800 watts, something like that. So you get a little bit of margin there.
So yeah, I think I'll run it again and see. I think it's running around 700 max. So,
yeah, cool. Well, it's been awesome. Until next time.
Yes,
I'll catch you later.
All right, thank you very much.